Hello, fourth graders. Welcome to another day of e-learning. Welcome to another day of fractions, and welcome to another day of getting smarter, getting better at these tough fraction problems. So as you can see, today we're doing this lesson 4 problem set. And it's going to teach us how to decompose our tape diagrams, decompose the shaded unit fractions into even smaller unit fractions. Okay, so let's try some sample problems and then you guys should be all good to go. So right off the bat, they're telling us that the total length of each tape diagram is equal to 1. Okay, so this entire piece is equal to 1. And they also already gave us our unit fraction. They gave us our unit fraction of 1/2 for 1/2. How do they do that? Well, we have 2 equal boxes, right? For now, you could ignore this dashed line in the middle, okay? We'll get to that in a second. But our unit fraction would be 1/2 or 1/2, because originally there were 2 equal boxes. How can we make those boxes even smaller? How can we decompose to even smaller number sentences and unit fractions? Well, let's just divide down the middle. And that's what these dashed lines represent. They're just telling us to divide down the middle. So now our unit fraction is not 1/2, is it? Our unit fraction is 1/4, or 1/4. Why is that? Because now we have 4 equal boxes. Okay, so since they already gave us 1/2, I'm going to use it, or 1/2, to represent this shaded part. So 1/2 or 1/2 is equal to 1/4 plus 1/4. Okay. And then for this next problem over here, the same problem, instead of dividing, so originally they just had these 2 equal boxes, right, to represent one figure. They had these 2 equal boxes, 1, 2, and they divided it in half to create fourths. And then they decided to divide it one more time. So instead of each unit fraction being 1/4, they turned out that each unit fraction is 1/8, or 1/8. And that is represented now in this number sentence. So representing the shaded region, 1/2 or 1/2 is equal to 1/8 plus 1/8 plus 1/8 plus 1/8. Okay, let's do some more sample problems. Let's do C. I want you guys to try B on your own. Play back the video if you need to, but I want you to try B on your own. C. Okay, so right off the bat, we know that this entire tape diagram is equal to 1, right? How do we know that? It told us up here. And we know that this small shaded region represents 1/4 or 1/4. This shaded region represents 1/4 or 1/4. How do we know that? Well, that's just the unit fraction, right? So we have 4 equal boxes and each represents 1/4. Now, how can I rewrite this in a different way? We could say that 1/4 is just equal to 1/4, right? But how can I decompose it in a different way? Well, I could just divide down the middle amongst each box. So instead of 1/4 or 1/4 is equal to just 1/4, we could say that 1/4 is equal to what would be our new unit fractions? 1, 2, 3, 4, 5, 6, 7, 8. 1/4 is equal to 1/8 plus 1/8. These are my new unit fractions because I just divided down the middle amongst each box. Okay, let's move on. We know that this represents 1/4. What if instead of just putting one straight line in the middle of each box, what if I wanted to put two? Okay, I'm just dividing it up. I'm just dividing it up into more equal pieces. Okay. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 equal boxes to make this unit fraction. And let's just focus on the shaded region again. So now we can also say 1/4 is equal to 1/12, or 1/12 plus 1/12 plus 1/12. Okay. Let's try some more sample problems. And now, so try D on your own. And let's look at, and also try 2 on your own. Apologize, Math Stars, that this lesson is a little long, okay? And that it's 3 pages instead of our usual 2. But that's just because these tape diagrams also take up a lot of space, okay? So 2 is essentially the same bit as number 1, okay? So rewind the video if you need to. But let's move on to 3. So now they're telling us to draw and label tape diagrams to prove the following statement. So we just have to prove that 2/5 or 2/5 is equal to 4/10. And the first thing they did was draw this tape diagram. And so the first thing they did was draw the tape diagram and then divide into 5 equal boxes to, so 1, 2, 3, 4, 5. And then they thought, what if I divide even further? Okay, so now I'm gonna put a line down each box. So now, instead of having my unit fraction be 1/5, my unit fraction would turn into 1 over what? Well, let's count to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each unit fraction now is 1/10. And just looking at our shaded region would represent 4/10 or 4/10. Okay, let's try another problem on your own, or together, I should say. Let's do D right now. Let's try to prove that 3/4 or 3/4 is the same thing or is equal to or is equivalent to 9/12 or 9/12. So I'm going to go ahead and draw my tape diagram to begin. This handy dandy tape diagram. And the first thing I'm going to do is try to represent this 3/4 or 3/4. And I know from looking at my denominator that I need to divide into 4 equal boxes. Okay, let's do that. 1, 2, 3, 4. How many boxes need to be shaded? Well, 3, right? Because that's my numerator. So I'm going to shade in 3. 1, 2, 3. Okay. Now I need to try to get to have 12 equal boxes. And how do I do that? How would I get 12 equal boxes? Let me just try to, first thing, let me try to add just one more line in each box. Would that get me to 12? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. No, it doesn't get me to 12. Let me try to add one more box into each of these boxes. Each of the original box, I should say. How about now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, I finally did get to 12. So now each unit fraction would be 1 over 12, right? Yep. And what represents my shaded, I should say now, very skinny rectangles into my tape diagram? What does this represent? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got my 9/12 or 9 over 12. My shaded 3/4 or 3 over 4 became 9 over 12. For me, simply just drawing equal lines into each figure, each box inside this figure. Okay? Let's do one more problem together. Let's try to prove, or let's try to show that 1/2 is equivalent to 4/8 by using a tape diagram and a number sentence. So first things first, I'm going to draw my tape diagram. And I'm going to first show this 1 over 2 or 1/2 on that tape diagram. Divided in half. How much would be shaded? Well, just one box, right? Because I'm representing this unit fraction of 1 over 2, so I only need to shade one box. And I'm going to try to represent 4 over 8 using this tape diagram. Okay, let's do the same thing we've been doing. Let's try to add a line into each box. 1, 2, 3, 4. I'm not at 8, so I know I need to add more lines, right? Let's add a line. Let's add a line. Am I at 8 yet? 1, 2, 3, 4, 5, 6. No. What happens if I add one more line into each original? Be sure about that, math stars. Original box. Okay, that you're only adding lines to the original boxes. Okay, let's try now. 1, 2, 3, 4, 5, 6, 7, 8. I'm finally at 8. So now each unit fraction would be 1 over 8 or 1/8. And my shaded region represents 1, 2, 3, 4 or 4/8. So I know that 1/2 is equal to 4 over 8. Or I can decompose this further. I could say 1/2 is equal to 1/8 plus 1 over 8 plus 1 over 8 plus 1 over 8. Okay? I know that this is super challenging, so please feel free to watch this video over again. Please feel free to join your teachers during office hours, okay? But I'm very confident you guys can do this. Ready? See you tomorrow, math stars.